Welcome to More Learn, More Teach, where I attempt to simplify the complex. Hello. Today I want to talk about ionization. So the concept of ionization is when you have an atom that will give up an electron. So this atom is relatively happy as it is with its 3 electrons. Yeah, I have my 3 protons on my lithium. If I want to remove this electron, it's going to require some energy. We call that the ionization energy. So I have to give energy to this electron in order to free it from this atom. That's called ionization. So where can that energy come from? It can come from a photon, or it can come from a charged particle, such as a proton, electron, something of that nature. So here's an example of how we can use this to our advantage. So I could design a detector of photons or of charged particles, depending on how I want to set up my detector. So what I have shown here is I have a chamber of some sort, and for simplicity, I used our example of lithium. So I've got lots of lithium in here, and I've got it hooked up to a battery. So I've got the positive end on this side, the negative end on this side, and I've got an ammeter. So I'm going to be measuring the current. Okay, so if I have a coating here that, say, blocks out all the charged particles, and the only thing that gets through here is photons, then I can measure photons. I can measure the strength of the photons that are getting to this detector, right? So I can have photons coming in here. Right, and then these photons will be absorbed, freeing that electron. So maybe that guy gets free, maybe this guy gets free. Once this is free, now I have a positively charged lithium ion and a negatively charged electron. The negative charge electron will be attracted to the positive charge plate. The positive charge lithium ion will be attracted to the negative plate. So you will have the lithium ions will be heading this direction, and the electrons will be heading this direction. This will complete the circuit and give me current. Okay, so current will flow, electron current will flow this way, right? So the electrons will flow through this circuit in this direction. The magnitude of this current is proportional to the amount of photons that were of sufficient energy to ionize this lithium. So it's going to be important to select the right materials, because you want to make sure that you're blocking out whatever you want to block out with the casing of this detector. You want to make sure that your material that's ionizing has the right ionization energy to detect whatever photon you're looking for, so that you can get a proportional current for whatever photon you are looking for. So I have here another detector. I have a neutron detector this time. So I have lithium 6 this time instead of lithium 7. And let's say I have neutrons. So I have neutron field coming in here. Neutron gets absorbed by this lithium 6 and becomes an excited lithium 7. Now, yeah, it's true. It can just become lithium 7 and be happy. However, sometimes it'll explode. And when it does that, it'll particle eject this alpha particle, leaving behind this tritium, right? So when this explodes, all of the electrons are ionized. Electrons will then go towards the positive plate, and the leftover nuclei are going to go towards the negative plate. And once again, I have current flow. So this is yet another example of why this ionization idea is important. All right, so here's an example of charged particle interactions. So let's say that I have an alpha particle that is ripping through some cell membranes. So let's say that this is a cell membrane, cell membrane. I've just got some outside electrons from the carbons, oxygens, whatever's on the outside of the membrane it's going through. This alpha particle, which is a helium nucleus, right? So it's 2 protons, 2 neutrons, with some kinetic energy. Well, as this charged particle is going to be passing through, it's going to be attracting these electrons, right, from these membranes as it's ripping through, but it's going really fast. So as it goes through, it will ionize these electrons as it goes through, damaging the cell membranes. Yes, it is slowing this guy down, right? Because you still have to conserve energy. So the kinetic energy of this alpha particle is being absorbed by the surrounding cell membranes, but we can see that we're causing a lot of damage as we are ionizing the cells as this alpha particle is traveling through. Right? So the more energy I have in this alpha particle, the more damage is going to be done as I ionize the cells as the alpha particle travels through. Let's try this example. Let's say I had a lithium and a fluorine that I put together. The ionization occurs when the fluorine atom steals the electron from the lithium. All right, so it does require some energy. That happens. Now I have a negative fluorine ion and a positive lithium ion. They bind themselves together. They're tightly bound. This is called an ionic bond, right? So it's not physically sharing electrons like our water was. This is, it gave away, the lithium gave away its electron to this fluorine. So now I have a charge on the fluorine, a charge on the lithium, but they remain in intimate contact. They remain ionically bonded. Okay, so now let's say that I had this lithium fluoride in water, right? So I've got lots of water molecules. We're at some temperature, right? So this is liquid water moving around. So as we discussed before, water is slightly polarized, right? So we have negative on one side, positive on the other side. And because of that, it will have some interaction on ionic compounds, right? So it'll have a tendency to dissolve ionic compounds. We're going to dissociate this ionic bonding. So what happens is you have this water that likes to wedge itself in between ionic pairs, and that will have a tendency to separate the ionic pair. If I didn't have any kinetic energy, then it would just reform, rebond, right? But since I have some kinetic energy in my water at liquid temperatures, it's going to continue move around, right? It's going to separate, reform, separate, reform, somewhat attach itself to the water, but not quite, right? It'll be constantly moving, right? So this works because the liquid water has some average random molecular kinetic energy, and it will keep the ion suspended, which will have a result of dissolved ions in the water. So that process is called dissociation. Thank you for watching my video. Please like and subscribe. If you have any questions that I can help you out with, I'd be happy to try and answer your questions. Send me an email at morelearnmoreteach@gmail.com.